How's everybody doing out there? Well, welcome to Corona Online School and Math 110. So this is a little bizarre for me, meeting you guys for the first time through a video. So this is definitely a new experience for me. And since you guys are going to be future teachers, this is probably one of the best lessons you're ever going to learn. Hopefully you'll never have to actually deal with this in your teaching career, but it's a very strange situation to be in. So if you're brand new to FCC, well, welcome to FCC. Usually at this point, what I would do is do kind of an introduction to the class, talk a little bit about me, then have everybody go around the room and talk about themselves. But to try to capture that same experience, we're actually going to do that through a collaboration. So what I'm going to have you do is do a little introductory video that you'll post on the collaboration page on Teams, so that way we can kind of put a face with a name and hopefully get to feel a little bit more comfortable with everybody. So, and I'll post mine up there as well, so I won't bore you with this video for that. And then usually after I do that on the first day, then I talk a little bit about the syllabus and stuff. So I'm actually going to leave that for you guys to read and just fire any questions that you might have at me about the syllabus or anything about the course and that kind of stuff. So instead, what I thought we would do is just go ahead and kind of jump into the math and kind of go from there. So just to kind of preface before we start, the main thing that we're trying to do in this class is we're trying to focus more on the education side of the math, not necessarily the math itself. Most of the math that we're going to be working on is at the elementary level, and hopefully a lot of this stuff you can actually do in your head, but what I want to focus more on is techniques to solve, problem solving, things like that, things that you're going to be able to offer to your kids and be able to help your kids learn different ways, because that's the one thing we need to remember. Not everybody learns exactly the same way. So later on we'll talk about like ways to add and multiply and things like that, and we may show 5 or 6 different ways, and you may not like some of them, which is totally fine, but at the same time some of these other ways may make it so a student who normally wouldn't be successful in math now has the opportunity to be successful in math. So when we're doing these problems, I'm not really looking a lot of times for the number answer. I'm looking for, the steps that were involved, what kind of things that you did, stuff like that. So don't do shortcuts or anything like that. Draw stuff out, write things, whatever it takes to get the answer. So again, this is kind of a weird class. Like you might want to have colored pencils, markers, things like that, because different colors are going to come in handy. You may need scissors, that kind of stuff. So no one has any questions or anything, we'll kind of move on here. So if we look at the very first thing, so we've got Polya's 4 problem solving principles. So these are nice, to think about for any math student in general. And usually when you look at a problem, hopefully first thing you do is just dive in and start working on it. Hopefully you read it, think about it, try to understand what the problem's asking. Then try to figure out, well, what am I going to have to do to actually solve this, kind of plan what to do, then actually carry out the plan, so actually go through and solve the problem, and then kind of look back, check your work, or explain it by writing it out in words and things like that. So in this first section, first 2 days we're going to be talking about nothing but problem solving. So we're going to talk about 5 different techniques today, and I'm going to go through and do an example of each kind, and there's going to be a bunch of practice ones for you guys to work on. That'll be part of the collaboration that you'll also do. So if we look, the different problem solving techniques that we're going to be working on are the guess and check, make an orderly list, draw a diagram or draw a picture, look for a pattern, and make a table in this case. So I'm going to go through, talk about which method I'm going to use for each one, and then kind of demonstrate what that method would actually look like. So in this case, Nicole is think of a number. If you double the number and add 5, the result is 13. What is the number? So right away, you might be able to know exactly what this number is, but that's, again, not what I'm wanting you guys to focus on. You also might notice there's kind of an algebraic way to do that. Well, if you notice, algebra is not one of our choices yet. We'll actually get to that in the next step. So for this one, I'm going to actually just kind of do a guess and check method. And so the nice thing about guess and check is if you don't get the answer right, it doesn't matter. It just gives you a starting point, and then hopefully from there we can use that starting point to move on to a next better guess in this case. So I'm going to guess, and it doesn't even have to be a good guess. I'm going to guess 2 and see what happens. So in this case, I'm doubling the number, which means I want to multiply my number that I guessed by 2, and then I'm going to add 5 to it. So in this case, my guess was 2, so I'm going to take 2 multiplied by 2, which gives me 4, and then add 5, gave me 9. So was that a good guess? No, wasn't a good guess because I'm looking to try to get 13. But again, that's kind of the point. Like, you don't have to get these right the first time. I know this is hard for students to think about, but it's perfectly fine to not get it right. So just kind of keep that in mind. So, but this does give me a nice idea because my next guess, like, I wouldn't want to go down, like I wouldn't want to pick 1 because 2 wasn't high enough to give me 13 as it was. So that means I need to find some number that's bigger than 2. So maybe I'll try 5 this time. So in this case, I guess 5. So again, I've got to double it. So I've got to multiply 2 times 5, which is 10. Add 5 gives me, 15. So in this case, that's no good also because I've gone too big this time. So again, that means I know my answer is somewhere between 2 and 5. So let's try picking 4. And again, the reason I'm picking 4 is because notice 9's a lot further away from 13 than 15 is. So it looks like I only have 2 choices. It's either 3 or 4. And so 3 must be a little too far away. So let's try 4. So 2 times 4 gives me 8. Plus 5 gives me 13. And so finally, the number that Nicole was thinking about was 4. All right. Is that okay? So again, I'm not looking for you to just put down the answer 4. You know, I mean, you don't have to miss it on purpose. If you get lucky and guess it right away, that's totally fine. But if it takes 3 or 4 guesses to get the right answer, that's good too. So again, just kind of keep that in mind. All right. So let's take a look at example 2. So list the 3-digit numbers that can be written using each of the digits 2, 5, and 8 once and only once. So in this case, we're trying to write 3-digit numbers. So for example, the easiest would be just to leave them in the order they're at, 2, 5, 8. So what I'm going to do is I'm going to use problem solving strategy 2, make an orderly list. So in this way, it kind of guarantees I don't miss any of the possibilities. So usually when I make an orderly list that looks like this, what I tend to do is sort of fix one of the numbers and then switch the other 2 numbers around. So in this case, I'm going to leave the 2 alone and flip-flop the second and third number. So in this case, 258 would be a possible 3-digit number, but so would 285. And so now I'm kind of going through all the possibilities with 2 as the first number. So now I'm going to do the same thing, put 5 as the first number, and I'm just going to kind of write them lowest to highest, so 5, 2, 8. So again, I'm going to leave 5 fixed, and then flip-flop the 2 and the 8. So in this case, we're going to get 5, 8, 2. And then so again, so that's all the possibilities with 5 in front. So now let's put 8 first. And then again, I'm just going to list the other 2 lowest to highest. So again, leave 8 fixed, flip-flop the other 2. And so in this case, we've got 6 possible numbers that we can write using the digits 2, 5, 8 in this case. And so again, by kind of doing this structure, keeping it as a nice list, it allows you to make sure you don't kind of forget anything as you're going along. All right. Any questions or anything about that one? All right, perfect. So for the next one, we've got Bob had 9 family members living at home, including dogs. Altogether, they had 22 feet. How many people and how many dogs lived at home? So we had 9 family members total. And then we've got dogs included in this. And so together they have 22 feet. So we're trying to figure this out in terms of how many dogs and how many people we actually have at the house. So this one, in my opinion, is just crying out for number 5, which is to make a table. So in this case, I'm going to do and so this one again is kind of like a guess and check situation because we may not get it on our very first guess. We may have to do this a few times. So the way I'm going to set my table up is I'm going to set it up with the number of people in the front, and then the number of dogs in the second column, and then the total feet in the third column. And so the thing to remember is we're going to put numbers in for the people and the dogs. So whatever numbers we put in for people, we're going to multiply that by 2 because in this case we're assuming all people have 2 legs. And same thing for dogs, we're assuming that all dogs have 4 legs, so we're going to multiply anything in the dogs column by 4. Now the main trick you have to be careful of here is that 9 family members. Where does that come into play? So what that means is if we take the number of people and the number of dogs and add them together, that number always has to equal 9 in this case. So for example, we could assume, this is kind of an extreme case, that there are 9 people living in the house and 0 dogs whatsoever. Now it's probably not right, but we can check it just to see. So if this were the case, then we'd have 9 times 2, because each person has 2 feet, plus 0, times 4, because in this case there were no dogs. So in this case, this would give us 18 feet total, which means we don't have enough feet. So in this case, we've got too many people and not enough dogs. So I told you it probably wasn't a good guess, but again, that's kind of the extreme that we're looking for. So what we want to do is just make sure whatever number I pick, so let's say I put 6 down for people, then I need to make sure I've got 9 dogs, because again, I want these 2 numbers to always add up to 9. So if I do 6 people and 3 dogs, I'm going to get 6 times 2 plus 3 times 4. So 6 times 2 gives me 12, plus 3 times 4 gives me 12, which gives me 24 feet. So in this case, we're getting closer. So we wanted 22, we started off with 18, now we're at 24. So what's this mean? So in this case, that means I've got too many feet. So that means I've got too many dogs included in the family. So let me back this up a second. Let's go back to 7 people and 2 dogs, because again, I want to make sure those 2 numbers add up to 9. So if I do 7 times 2 plus 2 times 4, I get 14 plus 8, which gives me 22. So lo and behold, that's exactly what I was looking for. So in order to answer Bob's question, that means that there were 7 people living in the house and 2 dogs that were living in the house. So 7 people and 2 dogs. All right, and so again, notice I didn't get it right on the first try. So keep that in mind. Like that's kind of the goal with these strategies. So there's a lot of kind of guessing and checking, just trying different answers and things like that just to see that we get the right thing. All right. If you have any questions about that, just let me know. All right, so let's look at example 4. So example 4, what we're going to do is look at the following sequences of numbers and then complete the next 3 numbers in the sequence and then try to figure out, well, what's the rule to get the next number in the sequence. So in this case, if we go back to our problem strategies, this one looks like it would be number 4, trying to look for a pattern in the numbers. So let's go ahead and put that down here. So let's look for a pattern. So things that we're looking for when we're trying to find a pattern is, we may try to look and see, what's the difference between the 2 numbers? Is it the same number the whole time? Does it look like it's being multiplied by something? Does it look like something's being added that's common to each and every one of them? So each one's a little bit different, but they all have different kind of strategies that you can use to figure out what's going on. So in this one, if I kind of notice, to go from 2 to 3, what I'm doing is adding 3. And if I go from 5 to 8, I'm also adding 3. And as I go from 8 to 3, or 8 to 11, sorry, I'm also adding 3. So it appears that the rule for this one is add 3 to the previous answer. So if that's the case, if I want to add 3 to 11, that's going to give me 14. And then if I add 3 to 14, that'll give me 17. And then finally adds 3 to 17, and this gives me 20. All right. So again, if either of these are confusing, feel free to, message me, send me a message through chat, remind, email, whatever, so that way I can help you with any of these guys as you're going through the classwork. So let's look at part B. So part B, we've got the numbers 1, 4, 9, 16, 25. So if we do something similar, so in this case to go from 1 to 4, what I did is I added 3. But when I go from 4 to 9, I added 5. So I didn't add the same number, but maybe this isn't lost, so let's keep doing that just to kind of check. So 9 to 16, I added 7. And then 16 to 25, I added 9. So it does appear there's a pattern going on. So notice that what we're doing is instead of adding like above 3 to the previous number every time, it looks like we're adding the next biggest odd number. So starting at 3. So we started with adding 3, then adding 5, adding 7, adding 9. So we're adding the next odd number in the list. So in this case, if that's true, then that means to 25, what we'd want to do is add 11, which would give us 36. And then to 36, we'd add 13, which would give us 49. And to 49, we'd want to add 15, and that would give us 64. Now I wonder if anybody else notices that there's actually another pattern that's going on between 1, 4, 9, 16, and 25. So you may or may not, but those numbers are actually all perfect squares. So if I take 1, multiply it by itself, I get 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, and then finally 8 squared is 64. So in this case, there was actually 2 different patterns that we could have actually used, and they both gave us the exact same answer. So notice I did the one below independent of the one above, and we still ended up with the 36, the 49, and the 64. So sometimes there can be more than one way to write down a pattern. So again, that's kind of a nice thing about these guys. All right, so again, those can be the kind of the trickiest ones. So if you're struggling with any of the practice problems, or even if you're struggling how I got these, don't hesitate to ask. Feel free to ask any questions. I'm here to help you guys. That's one of my favorite parts about teaching, is trying to help students to learn and get better and things like that. So, all right. So let's take a look at number 5. So how many tables that seat 4 people do you need for 29 people? So again, the only one we haven't done so far is draw a diagram or draw a picture. And that's what I would actually do in this case. So it's not necessarily going to be a diagram, it's going to be more of a drawing of a picture. And so what I would actually do is I would actually draw the tables and kind of put down numbers for each of the people up to when do we get to 29. So in this case, here's going to be a table, 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 there's going to be a table, and there's going to be a table. And I'm going to just pretend that I'm actually seating people at these tables. So here's person 1, person 2, person 3, person 4. And if you wanted, you could just keep going 1, 2, 3, 4, or you could continue 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So I need at least another table here. So 25, 26, 27, 28. So I'm close. So finally, I'm only going up to 29. So unfortunately, person number 29 looks like they're going to be stuck sitting by themselves at that table. But assuming we don't want anybody to stand and we want everybody to stay seated, it looks like that we actually need one table, 2 tables, 3, 4, 5, 6, 7, 8. So even though we're not filling up all the tables, it will take 8 tables. To seat all 29 people. All right, so that's all the different problem-solving strategies that we have for 1.1 through 1.3. So again, if you've got any questions or anything like that, so the next couple pages are actually practice ones for you guys to go through and do the exact same thing. So I am going to have you guys post pictures of your answers to the collaboration page, so that way we can kind of see if everybody used the same problem-solving technique, did somebody use a different problem-solving technique. It also allows us a way to check each other's work and make sure we're actually doing it right. Or you may see somebody that did it a different way and be like, oh, I like the way they did it, I might try their way instead. So I think there's about 8 or so practice problems on there. So don't post necessarily all of your pictures. Pick one of them out and post it. Maybe one that you didn't, that you did it differently than someone else did or something like that. Otherwise, good luck. Welcome back to the fall semester. Don't hesitate to ask questions. Again, I'll be on the computer all day, so if you have any questions, just let me know, and I'll talk to you soon.